This is the first question in the 2010 Light and Matter section. Over the last few centuries, scientists have proposed two conflicting models to explain the nature of light. One's a wave model and one's a particle model. Name a historical experiment that supports the wave model rather than the particle model. Explain how this experiment supports the wave model rather than the particle model. Alright, so the experiment that supports this is Young's double slit. The best way to talk about this is, I'll do my next point in blue, is to talk about what was seen in Young's double slit, was seen, and then explain that using either particle or wave. Okay, so in Young's double slit, just to remind you, there's two slits and the light goes in, and as it comes out you get an interference pattern here of bright and dark and bright and dark and bright and dark. Now let's write our answers in red. Alright, Young's double slit. What do we see? An interference pattern of bright and dark bands was observed. So this is the name of experiment, what we saw, we've done that, and explain this using either particle or wave. And so these bright and dark bands, these bands can only be explained by constructive and destructive interference. Spelled that wrong, didn't I? Destructive interference. And constructive interference is a wave phenomena, not a particle phenomena. So let's see if we answer the question. Name the historical experiment that supports the wave model rather than the particle. So we've done that. Explain how the experiment supports the wave model rather than the particle model. So what have we done? We said the interference pattern of bright and dark bands was observed. These bands can only be explained by constructive and destructive interference. This is a wave phenomena, not a particle phenomena. Yep, cool. Alright, next question. The photoelectric effect is an experiment that supports the particle model. So this is the other experiment you would have studied in class, rather than the wave model. The following are observed in the photoelectric experiment. The number of emitted electrons depends on the intensity of the light. The number of emitted, the energy of the, so this is the first of the number. The energy of the emitted electrons depends only on the frequency. So this is on intensity, this is on the frequency of the incident light. It's independent of the intensity. And the energy of the emitted electrons depends on the metal surface involved. The particle model can account for all three, and the wave model can only explain two of these observations but not a third. Select the observation the wave model can't explain and observe how the particle model explains this observation. Alright, so if you think about waves, if it was waves hitting this metal and electrons given off, if you've got a whole lot of waves, you increase the intensity of the light, which would be increase the size of the waves, and you get more electrons hit off. That kind of makes sense with the wave model. Observation 3, the energy of the emitted electrons depends on the metal surface involved. Yep, so that again can be explained with anything. It depends on the metal. So we've only got two left. The energy of the electrons depends only on the frequency of the incident light, is independent of the intensity. Now historically, people thought that if you make the waves bigger, the intensity bigger, the energy of the electrons would also get bigger, but that's not the case. The energy only depends on the frequency, not the intensity, not the size. So this is the only observation, observation 2, that can't be explained through can't be explained through the wave model. And so now we have to explain how the particle model explains this observation. Okay, so with the particle model, the key is that light travels as photons, or light exists as photons. Light exists as photons. Each photon has energy. Energy equals hf. Now, because each electron absorbs the energy of one photon, its energy depends on the frequency of that photon. Because each electron in the metal absorbs a single photon, instead of saying because each electron, because an electron in the metal absorbs a single photon, its new energy depends on the frequency of that photon. So we haven't done any explanation with waves here because it doesn't say to explain why the wave model cannot explain it. It says the observation explain how the particle model does explain it.